Hi, welcome back. In this specific session, I'm going to walk you through on two-way ANOVA. Two-way ANOVA is best used when we have gotten two categorical variables and then one continuous variable. Let me show you this with an example. We are presented with a problem where four salesmen are appointed to sell the refrigerators. Is there any difference in the sales made by the four salesperson? And is there any significant difference in the sales made during different months of the year? Here you could see that the salesman is a categorical variable and the month we have gotten is a categorical variable. Alongside, the sales performed by them is a continuous variable, ideal to perform a two-way ANOVA. Not only that, how would you identify a given problem is a two-way ANOVA? Whenever you are presented with two hypotheses, then you can consider this to be a two-way ANOVA. Two-way ANOVA calculation is more or less similar to one-way ANOVA except for one scenario. First, we will perform correction factor. Soon after that, we will perform total sum of squares. Third step is to finish sum of the squares between the columns. In this case, we are going to have it for the salesman and then we are going to perform it for the month. Based on this, we will calculate SSE, finally with the degrees of freedom, and then to toss it up, we will perform F-test. Let me set the hypothesis for this problem first. Here we have gotten two hypotheses. For every hypothesis, we have to set a null and alternate. I'm denoting the first hypothesis to be A. So we say all the four salesmen perform equally. Alternatively, they do not perform the same. They are different. Similarly, for the second one, also we are saying there is no significant difference in the sales made during different months, which is our B hypothesis. Alternatively, we say that the months plays a crucial role in the performance of the sales. And we are going to test this at 0.05. We have set the hypothesis. Step 1 is to reduce the table. We cannot deal with this entire table the same way as it is. We have to reduce it for an easier calculation. From the table, I'm going to pick up a number which is the multiple of it, 40 and then 50. Between these two, you can choose any number of your choice. I'm going to choose 40 to be the number. Once you have identified, subtract the number 50 minus 40, 10. 46 minus 40 will have 6. 39 minus 40, we will have minus 1. 40 minus 40, 0. 48 minus 40, 8. 44 minus 40 is 4. 48 minus 40, 8. 50 minus 40, 10. 40 minus 40, 0. 39 minus 40, minus 1. 45 minus 40, 5. 39 minus 40, minus 1. Once we have finished with this, let's do the total. 10 plus 6, 16. 16 minus 1, 15. 8 plus 4, 12. 8 plus 10, 18. 3. Simultaneously, let's do the column total. 10 plus 0, 10. 10 plus 8, 18. 18 minus 1, 17. 6 plus 8, 14. 14 plus 10, 24. 24 plus 5, 29. Minus 1 plus 4, 3. 3 plus 0, 3. 3 minus 1, 2. We have finished the row total and the column total. Now let's do a grand total over here. 17 plus 29, 46. 46 plus 2, 48. The column total is 48. Let's do the row total also. 15 plus 12, 27. 27 plus 18, 45. 45 plus 3, 48. So the grand total stands at 48. So the sum of all observation P equal to 48 in the data set. After reducing the table, we can calculate the correction factor. For calculating the correction factor, we need t squared upon n. The sum of total observation is 48, which we have derived it from here. This we are going to raise it to the power of 2 upon the total number of samples. How many salesmen we have? 4 salesmen. And how many months we have gotten? 3 months over here, which will give us 12. 2304 divided by 12 will give us 192 is the correction factor. Correction factor is done. Let's calculate the sum of the squares between for the salesman. We are denoting the salesman to be X and the months to be Y. So as a result of this, I have taken summation of X1 for salesman 1, salesman 2, salesman 3, and salesman 4. Summation of X1 is 15 divided by the number of samples inside this is 3 plus 12 raised to the power of 2 divided by 3 plus third salesman is sum of this is 18 raised to the power of 2 divided by 3 plus summation of X4 3 the whole square divided by 3 minus the correction factor of 192. 75 plus 48 plus 108 plus 3 minus 192. 234 minus 192. This will give us 42. Let's calculate sum of squares between the months. Months we are denoting it as Y. 17 raised to the power of 2 divided by how many salesmen are here? For the month, how many samples are here? 1, 2, 3, and then 4. Plus summation of Y square is 29. 29 the whole square divided by 4 plus summation of Y3 is 2. 2 raised to the power of 2 upon 4 minus the correction factor is 192. 72.25 plus 210.25 plus 1 minus 192. This one will give us a result of 91.5. Sum of squares between the months and the salesman is calculated. Finally, we need to calculate sum of squares of the total or how much of the variation is available with the data set. To calculate the total sum of squares, we have to square each and every one of the available variable. We are calling this as x1, so this will become x1 square, x2, this 2 will become x2 square, x3, x3 square, x4, x4 square. 10 raised to the power of 200, 36, 1, 0, 64, 16, 64, 100, 0, 1, 25, 1. This will become 137, 80, 164, 27. 137 plus 80 plus 164 plus 27 minus the correction factor 192 equal to 408 minus 192, 260. The total variation available for this data set is 260. We have finished with correction factor. We have finished with SSP for salesmen. And then we have finished SSP for months also. SST is calculated. The next one we have to calculate SSE. We have calculated how much is the difference between the months and between the salesmen. And what is the total variation also in terms of a SST. How much is the variation within the months and within the sales representative's performance? We were not able to calculate. That is what we are going to do now. So we are going to calculate SSE. The total sum of squares comes at 216 minus sum of squares between the salesmen 42 minus sum of squares between months 91.5. This will give us a result of 82.5. We are going to plug in all the variations in this table between, within, how much is the residual, and finally the total sum of the squares. The numbers here indicates the mere column, that's all. So how much is the difference between the salesman? 42. Between the months 91.5. Residual is 82.5. When you sum up these three, still you will get 216, which is what the total sum of the squares also will give us. For calculating the degrees of freedom, we are going to use it. For between the salesman information is represented by a column. So we are going to take column -1. How many columns were there? 4 salesmen minus 1 will give us 3. And how many months are there? Months were represented in row R minus 1. How many months were there? 3 months minus 1, which will give us 2. For calculating the residual degrees of a freedom, we'll be multiplying 3 into 2. 3 into 2 will give us 6 degrees of a freedom. So when you sum up 11 degrees of a freedom, we will have it. After this step, we are going to take the second column divided by the third column, which is nothing but the mean square. 42 upon 3 will give us 14. 91.5 divided by 2, 45.75. 82.5 divided by 6, 13.75. Fourth column, first cell. Fourth column, third cell. 14 divided by 13.75 will give us 1.018. 45.75 divided by 13.75, 3.33. The one that we have performed is called as a F test. We have finished with all the calculations. Right now, we need to compare it with the critical values. F calculated value, F table value. For the salesman, we have calculated a value of 1.018. For the months, F calculated value is 3.33. For both, we need to find the critical value. Here, between the salesman, the degrees of freedom is 3 and the residual degrees of freedom is 6. The intersection is our F table value, 4.757. F table value is 4.757, which means if the values, calculated values are going to be on 4.757 or after that, we will accept H alpha. But whereas in our case, we got in a value of calculated value is 1.018, which is much before 4.757. If the values are going to fall before the critical region, we will accept H naught. If it is after the critical region, then we will accept H alpha. So the rule card is F calculated value is greater than F table value, accept H alpha. F calculated value is lesser than F table value, accept H naught. F calculated value is lesser than F table value, we are accepting H naught. There is no significant difference in the salesman performance. Let's find F table value for the months. The degrees of freedom for the months is 2 and the residual is 6. The intersection value is our F table value, which is 5.143. 143. So the F table value is 5.143, which means the calculated value that we have gotten, if it is going to fall either in the critical region or after the critical region, we will accept H alpha, otherwise we will accept H naught. F calculated value is lesser than F table value, which is 3.33. It is not outside the critical region, it is within the region. So we are accepting H naught. Since F calculated value is lesser than F table value, accept H naught. So there is no significant difference in the sales made during the months. So we have proved that there is no significant difference between the performance of the salesman and the sales made during different months. That's it. We have finished the calculation. Yes, I can hear that. It's so easy and simple. The key over here is identifying is it one test or two test. When two hypotheses given, it's a two-way ANOVA. I'm sure you have enjoyed the video. Should you have any questions, please do post it in the comment box. I'm happy to answer it. Thank you so much for joining me. See you in another video. Until then, this is Karpakam signing off. Good day.